Hello folks, we come to the exercise 1.3 part 3 and this is going to be an extremely interesting question where they're asking us, they're giving us a function f and they ask us to find the inverse of f. First of all, they ask us to find whether f is 1 to 1 and then find the inverse of f. That is how the question goes. So let's find whether it, let's prove that it's 1 to 1 and then let's find the inverse. So let's start right away. So let for 1 to 1. This is for 1 to 1. Let f of x1 be equal to f of x2. So that means x1 by x1 plus 2 is equal to x2 by x2 plus 2. We cross it over. So x1 times x2 plus 2 and x2 times x1 plus 2. So that is x1 x2 plus 2x1 and x2 x1 plus 2x2. This can cancel. You have 2x1 equal to 2x2, which will be finally x1 equal to x2. So what happens is, starting with f of x1 equal to f of x2, we have shown that x1 equal to x2. Like that, f is 1 to 1. Now they have asked us to find inverse, or what is the question? Let me check. Find the inverse. So for finding the inverse, what we do is, like the idea that we applied for onto, we are going to apply that same idea. Let y be equal to x by x plus 2. Okay, now we do our little bit of working. So this goes there, yx plus 2y equal to x. This goes here, 2y equal to x minus yx. That is x times 1 minus y. So what is x? It is 2y by 1 minus y. Should always get x equal to something, right? That will help you define a g. When you define a g, eventually that will become the inverse. So this is the same idea which we use for ontoness also. That same idea we'll use here to define the inverse. Eventually it will turn out to be the inverse of the function that is given to us. So let's make this intelligent definition. Define g from where? Just the opposite, from r to minus 1 1, such that g of x is equal to 2x by 1 minus x. R minus 1 we should define. We will require r minus 1 because if x is 1, then yeah, we'll define it. I will see how it is coming. Now what we will do is, we will have this values considered. Consider g o f of x, which is g of f of x. F of x we know it is x by x plus 2. G of that value is this, 2 into bracket value, 2 into bracket value by 1 minus bracket value, equalize. So x plus 2, x plus 2. So 2 x plus 2 minus x by x plus 2. X plus 2, x plus 2 cancel, x gone. So 2x by 2 left, so x is left. So you are having GOF at x as x, which is also called as identity of x. Also, FOG at x is f at g at x. That is f at 2x by 1 minus x. What is the f definition? That it is x by x plus 2. So it equalize. So what will come? 2x by 1 minus x whole by 2x plus 2 minus 2x by 1 minus x. 1 minus x, 1 minus x cancel. 2x, 2x cancel. 2x by 2, which is x. So let's continue here. Thus GOF at x is x and FOG at x is also x. the identity latex. Whenever such a thing happens, therefore F is invertible and F inverse is G. Okay, so that's how the definition will be for this. About the inverses, how we go about doing the inverse. Now quickly we will continue with the problem number 7 also, which is also the same. They give us a function from R to R, they define it as 4x plus 3. They ask us to check whether it is invertible and then find the inverse of f. That's a question. So check whether it is invertible and find the inverse of f. Same idea, we'll define the g and then, so first to define the g, we will first say 4x plus 3 equal to y. It's a trick, right? So 4x equal to y minus 3, x equal to y minus 3 by 4. This is going to be your definition, y minus 3 by 4. This is your definition. So define g from R to R itself. Yo, why did I rub it? My god, 4x plus 3 equal to y, 4x equal to y minus 3, x equal to y minus 3 by 4. So g from R to R is such that g at x is x minus 3 by 4. So these are definitions. Now let's start with the GOF and consider. G of f of x. So that is 4x plus 3. G of 4x plus 3 is the G definition is this: 4x plus 3 minus 3 by 4. So this is gone 4x by 4, which is x. Also FOG at x is f at g at x. So that is g at x by definition x minus 3 by 4. F will be what? 4x plus 3, yeah, 4 times plus 3, got one, x minus 3 plus 3. So that is x. Therefore FOG at x is x. Hence, or thus, GOF at x is x and FOG at x is also x. Therefore f is invertible and f inverse is g. That's what they've asked us. What is f inverse? We are told that f inverse is g. That's all in this video. With more problems, we'll meet in the next video. Thank you.